Academy Foundation presents the fourth law. The first three define an object, apply energy, and redistribute things in time. In the fourth law, to convey on an available path, temperature and entropy must be mixed by a change process. Warning, this topic is math logic intensive. Please wear a helmet. Behold the case for entropy reduction, predating Clausius's first mathematical conception of entropy by 30 years. The job of the condenser coil is to reduce entropy by providing a means for heat to escape. Let's prettify this 1882 drawing by John Hague. Angular momentum, like a passing stream, turns the wheel and converts to linear pressure, which is applied to the primary coolant in a closed cycle. The cycle passes through a helix called a condenser coil. The coil is converting pressure to temperature, effectively mixing them so they can emit as heat. Very likely, the water driving the wheel is being used to ferry the heat away. The loss of heat reduces the coolant's entropy, providing low potential for heat to flow away from the water being frozen. A cycle does not need to be a literal circle, but shape can be significant. Let us begin with cycling the unit circle. Theta begins at 0 on the right and goes around to 2 pi. The cycle links two functions used for measuring two sides of a triangle. Each side is an axis perspective, like two people looking at the same point of the cycle. Cosine is a real circular function connecting the cycle to a length on x. Sine is a complex function connecting to y. Anyone looking at this would call this complex, and these variables are appropriately named complex variables. On the left are polar graphs. On a polar graph, negative values go the opposite direction of positive values, such that the negative value of sine overwrites the original positive circle. Cosine is a Boolean OR function. It doesn't matter if you rotate the angle positively or negatively, the answer is the same. Sine is a Boolean AND function. Positive and negative rotations have the same results, albeit in neighboring quadrants. Unlike cosine, that is ideally represented by a cycling circle, sine has a tetrahedral shape, making it complex. Both functions are bicomplex in that they relate to axes. Euler recognized that a flat xy plane is imaginary. He used the arc shape of I to rotate the imaginary y-axis onto the real plane with x. This generated the third z-axis, which makes for a real volume of space. As a flat circle, cosine is real, but sine is imaginary. Rotating those circles into the familiar wave shape makes cosine imaginary and sine real. In the process, you can clearly see the circle first passes through a phase shaped as a helix. Even here, a rotation is being used to transform the nature, and in the middle of that process is something that conveys. No, these aren't gang signs. They are Fleming's rules distinguishing how types of energy apply in different perspectives. The initial perspective is that of a right-handed generator, followed by a left-handed engine. The generator focuses volume into pressure. The left-handed engine then disperses the force. Linear or angular volume is focused by the generator into angular or linear pressure. That pressure applied to the engine emits as volume. Because electrons act as intermediaries in electricity, the input is rotated in and arrows for the current are reversed. Sine and cosine in context combine to create a circle, sphere, torus, or helix. Each combination is an applied form of hypercomplex H. Each change function is bicomplex, meaning they relate and mix two axes. Now let's think of it in more concrete terms. Light propagates because it is a complex mixture of values. Eventually, the details of that mix reach a minimum value and differentiate as free space. Free space is standing energy providing background temperature and temporal pressure. Free space is just there, acting like the tracks of Leybourne's uphill roller, providing an enabling path for light to propagate. Euler again translated these concepts into the language of mathematics. If Leybourne's roller wasn't on his mind, then maybe the algebra rule of mirroring operations was. Or the third law, these laws of physics always apply. Free space is also available to be mixed. The standing pressure and volume are polarized into angular and linear roles. The way they are mixed accounts for nearly the entire table of virtual particles. Neutrinos are highly informative. Like all virtual particles, neutrinos generically fall into three categories consistent with the types of triangles. Each triangle combines emission and absorption into a bicomplex. Energy to accelerate can only act on the available absorption space. The lowest mass has the greatest amount of available space. Red and blue colors have linear emission, where green has angular. The anti-colors reverse the roles. Then we use the color charts to show how these interact to construct and evolve the nature of space. Which brings us to the internal Boolean logic of our change functions. I and j synthesize into the hypercomplex both. Their transformations into each other are resisted by time, acting as the Boolean knot. You'll notice the rules mirror each other, so the squares of h, I, and j are -1, and their chirals, h', I', and j', square to +1. They also do strange things like j plus j equals 0, and j minus j equals 2j. As the algebra to the right shows, these have effects on very specific axes. The rules table also separates the complex variables from the truth table. Traditionally, truth tables for tessarines and quaternions depend on internal group logic. Here, the individual logic created by the group actions evolves into individual actions creating group logics in real numbers. That's a mouthful. The latter, octonions, are a form of quaternions. We've only scratched the surface of change functions to make our case relating rotations to transformations. Euler got us started with complex variables, but Perkins showed us how mechanically. Now we can use the evolved logics to understand how light propagates, the strong interaction forms matter, and much more. All because heat, as a mixture, can convey, but temperature and entropy by themselves are static variables. Quantum relativity conceptualizes advanced topics in established physics to provide educational and practical tools. Our biggest problems in physics are human, specifically too much information and no accurate standardization of the concepts. Basically, advanced physics needs an introductory class to put it all together. Remember to subscribe and stay tuned for other educational videos. Thank you.